Good day, everyone. Thanks to everybody, who's joined, the webinar. We're, 4 minutes past our time. My name is John Praveen. I'm the Chief Solutions Officer at KANINI. We are a digital solutions enabler. Um, can you all hear me? Karthik, can you hear me?
Yes, we can,
Yes.
John.
Yes.
Awesome. Okay. Um, Glad to welcome all of you to this Kanini Connect session on behalf of all the management employees of Kanini Software. Today, we have Sundar Kupaswamy, Chief Data Scientist at Asurion, Prabhu Venkatraman, Head of Digital Technology and Products at Larsen and Toubro, and Sudha Ganesh, Vice President of Strategic Initiatives at Kanini, join me today. Um, without taking much time, I'll give a quick introduction about our guest today. Sundar, thanks for joining. Sundar has more than 20 years of experience in building data science and machine learning teams to create value. Uh, and Sundar and his team have built multiple AI applications across diverse domains, be it around customer experience or supply chain operations, multiple areas. Uh, Great speaker for addressing some of the questions today. Sundar holds a master's in systems and industrial engineering and optimization. He's a technical advisor and a board member for the graduate program for analytics in Georgia Institute of Technology. And Sundar is based in Nashville. Uh, he's also a very competitive tennis player. Um, for those who look forward to playing tennis with him, right? Our second speaker today is Prabhu. Prabhu has a couple of decades again in the industry running digital initiatives for providers like TCS, L&T now. He's been at the forefront of digital transformation for many industries, healthcare, construction, manufacturing, and has worked for multiple organizations of Fortune 500 repute. Prabhu has helped to build the digital transformation team in L&T over the last 4 years. Prabhu is an electronics engineer. He's based in Chennai, and Prabhu's a flautist, right? So if you're probably still hearing the music, that's not Prabhu, but he can do a better job than that, guys. Uh, Finally, the third speaker that we have, Sudha. Sudha has more than 20 years of experience, having worked with providers like Delta, TCS, and L&T Infotech. Sudha brings the expertise of having worked with large transformations in diverse environments, especially with Fortune 100 clients, providing value-based solutions. Sudha holds a master's in software systems and is based in Chennai. Sudha is also the sponsor for the analytics organization in Kanini. Um, Sudha is also very passionate about gardening, travel, and volunteering for NGOs. A little bit about today's topic. Most of us in the data sciences function or the business side have always wondered about how either the time taken, to build models or the usefulness of those models, um, are always there's a challenge. So and especially when we open the gamut of unstructured data, right, text, image, all of that, how do you optimize both speed and the usefulness or perfection of those models? That's the topic that we chose to discuss, and we have fantastic speakers on that topic today. Uh, I'll start my first question to Sundar, pretty much to set the stage even before getting into any of all that. Sundar, there's a lot of discussion about data sciences, AI. People talk about deep learning, machine learning. Do you want to clear the air, talk about how all of these are connected and how these are different?
Hey, John. First of all, thanks for the opportunity for us to share our experiences and knowledge with this forum. So thanks for you and the team for that.
Glad to have you here. Yep.
And nice to meet all of you fellow speakers. Um, so in terms of your question, I'm sure all of us have a view on it, but when we think of AI, which is a broad field, and you see multiple definitions still being debated on the internet, so I wouldn't say there is one perfect answer to that question, but I can share what I think about it. The way I view it is when we use computation and machines to perform tasks that would normally require human intelligence, then we can say we're using artificial intelligence. So that's how I view it. And machine learning, data science, deep learning, all of them are components within that. And when we talk about data science, again, the way I think about it is is the application of scientific and statistical methods on the data to primarily do two things: either build smarter products or making smart decisions. So that's the way I think about it. I hope that answers your question.
Awesome. Thanks. And just for all our attendees, quick uh, intro on the format today. We will have a few questions that we bring up to Sundar, Prabhu, and Sudha on this topic. Meanwhile, feel free to put your questions on the chat window or the Q&A window, and we will take up those questions towards the end of the discussion. Sundar, thanks for getting the clarity around data science, ensuring and kind of clearing the air there. Quick follow up, on the topic itself. What are some of the challenges that you've typically seen hinder the speed of a data science effort?
In terms of challenges, I think there are multiple challenges. It starts from challenge in understanding the business context of what problem you want to solve. Challenges in terms of getting your data ready for doing the work, what we call data preparation, data cleaning, data normalization, pre-processing, all that stuff. So technical challenges, I would say, over there. Data is also never perfect. It's never complete. And that's another challenge. And then also in terms of communicating and measuring the impact of the work that's being done. I mean, these are all, there are challenges pretty much in every step of the life cycle. I would say just the challenges vary from a business challenge versus a technical challenge versus an algorithmic challenge and so on. So I think that's how I view it.
Awesome. Okay. Prabhu, do you want to chip in? No, is there, something that you've seen from a business and a technical side, what you've seen as challenge in addition to what Sundar just brought up here? Prabhu, you're on mute, so you may want to unmute.
Yeah, sorry about that. No, I think that's a great question, right? So I think Sundar pretty much addressed the technical challenges part of it, right? So, but the most important challenge in bringing speed or accuracy to any data-oriented project is the human, right? So the typical understanding of what a particular um, data initiative is going to yield is something that in many, even in established organizations, even in established with established teams, it's very difficult to get everyone on the same page before we do a couple of iterations and establish that harmony, right? So that I see as an important challenge. So it's very difficult to make everyone understand what is the problem that we are trying to solve. However clear the problem statement is, with the field of data science and with what we can do with data, with the possibilities being endless, people have different interpretations of what a problem could be and what the solution, of course, could be, right? So if there are two interpretations of a problem, there are going to be like 4 or 5 interpretations of the solution, right? So I think that is one important challenge that I see to hampering the speed of what we do with data.
Thanks, Prabhu. I see. Thanks for bringing that aspect of it as well. Before we move on to further questions, uh, folks, we have a quick poll coming up. Just to see how many of you see this as a challenge in your own organizations. Um, is this a concern? I mean, is this even a concern that is bothering some of you? Feel free to let us know your thoughts. Yeah, moving on to further questions. Assuming you had the time to click on that response there. Sundar, again coming back to you. Now, yeah, you did talk about the different types of challenges, right? Of the algorithmic challenge, or the business challenge, or the technical challenge. Do you want to break down the whole life cycle of a data scientist project, especially when you use unstructured data, and give cite any examples of where you've seen data scientists and most of the time?
Sure. In terms of the high-level life cycle, the way we work is first understand the business context, just so that we are clear on what problem we are solving and why it matters, right? So I think that's important. And then obviously, when we start jumping into the data to address that problem, we need to make sure we can, collect the data, make it analyzable, etc. So a lot of cleaning and preparation, is another part of another step in the cycle, I would say. And then after that, a lot of exploration happens, because typically in this field, it's not requirements oriented. In classic traditional software development, you're given requirements, you're given specs, and you build against it, and you provide your solution, right? Whereas in this field, it's very exploratory in nature. So it kind of becomes like a chicken and egg kind of a problem. Sometimes you have to show what the solution looks like to excite the people to accept uh, the solution, like prototypes, proof of concepts, all those things. At other times, you may not know how to even start if you don't know the business context, right? So it goes back and forth a little bit. So exploration is important, and you don't even know if you can solve the problem. You have a hypothesis that you feel you can solve it, but you can either prove or disprove your hypothesis. So exploration, I feel, is a very important part, but it's taken for granted as well. If you look at it from the other lens, you expect quick solutions in a given amount of time, right? So that's one thing. So feature engineering and modeling is all part of that algorithmic work, and it's not just to improve the accuracy or the predictive power of the solutions, but you have to think of you don't want to make your model too complex to implement or to be scalable from a technical perspective. So a lot of feature engineering and modeling goes into it. Measuring the impact and communicating it is important, because you have to link it back to the problem that you wanted to solve in the first place. Um, doing that, and I think that's the typical cycle. Maintenance and recalibration is important, because once the model is in production and it's working, it can degrade over time. If you think of classic machine learning models being trained on certain data, it can get over biased, or it can stagnate over time, and you want the feedback to constantly improve the performance of the model. So the maintenance and calibration is important. So a lot of measurements and stuff there. So it's a typical cycle that we go through.
Got it. So if I heard you right, you said, hey, first step is domain expertise, understanding the domain, then data collection, data preparation, exploratory analysis or analytics, then feature engineering and data modeling, and then you talked about maintenance and recalibration. I just want you to within these different areas, where do you think, whether it's data scientists or data engineering, resources, where's the time spent the most, right? Which part of it do you think contributes to the longest one within the CPM or critical path?
Yeah, I mean, typically you would have heard that data preparation is the longest tail from a technical standpoint. Uh, you would have heard 70% of a data scientist time is spent in data cleaning and data preparation and all that stuff. So I would say that's one key component. I would also say the start and the end is important. Understanding business context, again, sometimes takes a long cycle. It may not be coding, but more conversations and debates, disagreements, alignment, whatever. That sometimes takes time, and that's beyond the data scientist's time. It's also the business domain time, as well as towards the end. If we do a good job upfront, I think we make the last step easy, which is measuring and communicating impact and seeing if it's really solved the problem. So these things are also take some time. So yeah.
Got it. Hey, Prabhu, coming to you from the business side, what are some of the typical challenges you've seen with the usefulness or the perfection of the data model, right? There are times, when in some organization or some areas, you go through the whole cycle, um, and there's a miss somewhere, right? What are some of the barriers or things that you think contributes more to the perfection or the usefulness of that particular model to solve a problem?
Yeah, so when you look at the perfection of the model, right? So it all depends on what is the base data that you're going to use to train that model, right? So like the popular saying goes, garbage in, garbage out, right? So the quality of data plays a very important part about how it's going to function. And like Sundar was mentioning, is the model going to degrade over time based on how frequently your data changes and so on, right? So that determines the perfection of the model in a way. There's another point as well, right? So I'm always fond of the human aspect of it, right? It's human in the loop. So when you have a human in the loop in trying to provide feedback and trying to improve the model or whichever way it is, right? In a hurry to get a data project initiated and executed successfully, we sometimes get the wrong human in the loop, right? So, for example, if you're trying to look at a supply chain automation and you're trying to do AI on supply chain, you should get a person who has been in supply chain and who has been with that domain for a long time, so he can decide on what feedback to give for the prediction or for the classification that the data has been doing, right? So in a hurry to do, speed up that step because the domain expertise is not available on time, or maybe they are busy or whatever it is, we try to get some person who can do that, thinking that this is one step in that whole analytical process, right? And that screws up that whole data, and it creates a mess which is beyond any of us to solve, and you end up starting that whole thing again, right? So this is one of the very important things that deals towards perfection. In many cases, we've also seen that there is considerable bias in the data, right? So it depends on what data you're taking, right? So it cannot be narrow focused on a particular time frame or a particular persona's data, or even if you're talking about IoT data, it cannot be one particular machine's data or one particular period's data and so on, right? So that creates a lot of bias in that data. And it also what kind of mechanism that you use to collect that data, and when do you acquire that data, all that also builds that bias, right? So progressively. So this is something that I think these are three things that come to my mind about. Of course there are multiple problems, but these are three problems that are quite often overlooked, so I wanted to bring that in onto the table.
Understood.
Hey,
Um,
Yeah, John, sorry to disrupt your flow, but I remembered something for your earlier question in terms of challenges that I think I failed to mention, but I think Prabhu touched on it. He said human is important, right? So I think as a leader, I feel the number one challenge is talent, I would say.
Yeah.
Uh, because the demand is huge, and also you have to find the right talent who can make it applied versus being just research oriented or academic oriented, and all those classic challenges that you see. I think finding talent in this space is also a very important challenge when it comes to leaders, and how you overcome it, and the investments you do to make sure you get the right talent, because without that, I think it's hard to do anything. So just wanted to point that out.
Thanks, Sundar.
So Sundar, burnt finger always makes you remember things, right? So I burnt my fingers on that when we were working on one model for using natural language processing to train for risky clauses for contract documents and so on. So because we were not able to get a trained contracts or a tender kind of a person, someone put a trainee who has just joined the team to train for important clauses and risky clauses, and you could expect what the result would have been.
Thanks, Prabhu. Quick question on what you touched upon. You said, "Hey, data. I mean, garbage in, garbage out." Right. So perfection is really dependent on the data that you get. So my next question to you is, what's been your experience in collecting data, right, and across different channels, and especially the usability of it? There are times, you know, data exists, right, but how usable, for the problem you want to solve it, and the just the land grab and the challenge to get the data in that place. What's been your experience with that?
Right. So when you look at this, right, so I would rather divide this space into two categories, right? So one is human generated data, where you're talking about, say, for example, if there is since we've done this digital transformation and I'm fresh out of that journey, I'm bringing one example from there where we're talking about an application that a mobile app that people use for recording industrial safety observations, incidents, lost time injuries and stuff like that, right? So when they use this, we implore them to record free text rather than, categorizing the observations and saying, I'm recording an unsafe act or an unsafe condition or a, place where materials are not kept safe and so on. We implore them to record that in free text. So, using AI or NLP, we will be able to understand and classify it better than the user actually could, right? So in that kind of a model where the human is actually the person who's generating the data, the collection has always been trying to tell them how easy it is for them to enter data rather than select from a given set of choices and go ahead and express themselves on that data better. So we would be able to glean inputs and insights from that, right? So that has been one case where the human data has played a part, but largely the data collection challenges from machine data, right? So now that's the second category of data that you would talk about, where most of that data that has been out there right now is all IoT data or machine generated data. So now when you talk about machine data, the understanding of how we can collect that data goes to building a platform, right? So you need to understand what data you should acquire first. So what is the problem that you're trying to solve? And based on that problem, what is the data that you're going to acquire from that machine, right? So machine is going to give you loads of data. Sometimes the machine doesn't give you data. You will have to retrofit it with sensors. So you will have to precisely understand which is it that I would want to do. And once we do that, getting that data onto a platform, on the prem or a cloud platform or something like that to ingest that data, run it through a hot path or a cold path and process it, and then do some initial cleanup, brush up that data and store it in a processed area, and then go forward with that processing, right? So that calls for a platform approach where you would be able to acquire data from these machines, store them in a consistent fashion, ingest them in a very consistent fashion, and also be supportive of the fact that machines are going to give you a lot more data with a lot more frequency than human generated data, right? So I think these two categories call for different understandings to understand what is that challenge that I'm dealing with and how do I deal with that data, right? So that's my 2 cents on that.
Okay, thanks. Quickly, you also, both of you, Sundar and Prabhu, both of you talked about talent being very key. Prabhu, you give an anecdote of or an example of how you burnt your fingers, with a trainee there. So, how important is domain expertise for perfecting data models, right? Have you seen, instead of analysts with all that experience, have you seen sometimes when you don't have an analyst with carry that experience, a SME being planted into that project to ensure the success of that project? What do you guys see about the need for domain experience, expertise, and how have you seen that being played by different organizations?
Right.
Uh, One of you can start, either Prabhu or Sundar. Give your thoughts there, guys.
Sure. So since Sundar is on mute, I'll take the first cut at it, right? So see, what we have seen is that I'll go with an example again, right? So there have been cases where we have built predictive maintenance models on some asset types and some equipment types that we deal with, large equipments that typically construction, mining, manufacturing uses, right? So when you deal with that kind of a predictive maintenance kind of a model, there is a very important underlying aspect. I have the data, right? And of course, when I go through the data, even a layman would be able to find some patterns in that data. But the inner meaning of what those patterns mean to the operation of the machine is something that a pure data analyst will not understand, right? So there is where the SME comes into picture to say, hey, you know what? When the pressure, the hydraulic oil pressure in this particular area spikes up, and the temperature is low, that means there is a lot of friction in the bearing, and your machine may fail probably in a couple of hours or so, right? So this kind of inference is something only an SME or a person who has knowledge in that makes, right? But that said and done, is it possible for us to get a person, a resource, who is both a data scientist and an SME from predictive maintenance? Your probability of that is almost zero, right? So we've tried our best to look for people like that, but it's very difficult to get that kind of a person. So obviously you will have data scientists who will do the initial cleaning of the data and who will work co-located with, work very closely with the SME in every step of it to understanding that data. And when you do a project, when we started this particular predictive maintenance project, it took about anywhere between 4 to 6 months for us to come up with the predictive maintenance model with a reasonable accuracy for one equipment type, right? So in that kind of a case where we started with one data analyst or a data scientist who did not have an experience in predictive maintenance and an SME, by the end of the 6 months period, going through the failure mode analysis, which we call as FEMA and stuff like that, right? So going through all that data with the SME, slowly the data scientist picked up, that whole language and said, okay, I'm now able to do predictive maintenance. But when we were switching to a different asset type, we did it for boilers. When we wanted to do it for turbines, the data scientist again had to start from the beginning, right? So SME support here is very imperative. And I don't think a data analyst or a data scientist, however good he is going to be able to do it by himself.
Sundar, do you want to do you have a view on this?
Sure. I think the short answer is yes, it's very critical for the domain expertise to be there. In one of your previous slides, you had said most models are wrong, some are useful. And I feel, some of the contributions that the subject matter or the domain experts can bring in is a feeling of what is good enough when it's not perfect, right? So we call it at Asurion, we call it minimal viable product, MVP, right? So we say that's enough for us to. It's not perfect. It's one way to speed things up, is to say this is useful today versus my current state, and that's progress, right? And to do that, you definitely need the business context and the input, because especially if they are the users of the solution, you need them right from the get-go. So we work with cross-functional teams. So a data scientist, a domain expert, a designer if it requires an interface, an engineer, a combination of all these folks who work together just with a common goal.
Got it.
There may be some cases where some research and exploration is done on the side separately, but they are always in constant touch with this physically co-located or remotely these days. But to maintain the context, it's very key, especially if you're new. And I think to Prabhu's point, it's tough to find a unicorn who's good at everything. So we also try to train people who are in the business domains with certain skill sets. So that's what we try to do to bridge that gap. But I think working together in a cross-functional team is key.
Perfect. Time for another poll. All attendees, if you want to quickly tell us what's your data sciences team in your organization like, that'll be very helpful. As we get the poll answered, we move on to more domain-related questions. I think we now said, hey, domain's important. So Sudha, you've been a little silent, so I like to kind of direct to you. And want to now look at healthcare, right? Now that we started talking domains, let's pick up healthcare, especially a domain like healthcare, where there are so many data regulations and challenges of data being moved anywhere. Where do you see use cases? How have you seen the success of, data analytics in, an industry like this?
Yeah, that's an interesting question, John. So, when it comes to data analytics in healthcare, I have recently seen market research that says like by 2022, data analytics, especially augmented analytics, is going to be ubiquitous, but it may not be used to its full potential. So healthcare industry is rapidly evolving as one of the leading industries in digitization because there are many transformative forces like the technologies, disruptive innovation, or new virtualized ways of working. So these are actually changing the way that we are working. So there are many business-driven use cases, I would say, with the digital care records like the EHRs, EMRs, health insurance exchange platforms, and regulatory compliances like HIPAA, HL7. There is a need for next-gen analytical interventions, and it's on the rise, and healthcare organizations are adopting to it because meaningful use of data is one of the key challenge with any healthcare organizations with all these digital care records. So the next-gen analytical-driven offerings would help the healthcare professionals to achieve better outcomes, lower the cost, and to provide a better patient experience. Like when I say to provide a better patient experience, I can take, for example, there are like you can have a conversational AI platform, which is like a bot platform, like it's a kind of a 24/7 customer service representative. It can handle the patient inquiries, or it can handle like patient appointment bookings, doctor visits, etc. So that's going to give a complete patient engagement, and it can actually come up with a follow-up visit so that the providers can actually come up with a very value-based care delivery models. And when it comes to better outcomes, there are many AI-enabled clinical decisions. Say, for example, I can use image analytics or computer vision for for lab reports, say for X-ray scans, and that can help the physicians in better and quicker and accurate diagnosis. So that's one strong use case that we see in the healthcare industry. And the other one can be like the predictive analytics on the claims, like coming up with the probability of claims that are going for your utilization management or case management, and predicting, hey, these are all the claims that may result in adjudications like adjustment of claims or claim denials. Which is a major challenge with the healthcare industry. So this can actually, coming up with the predictive analytics on this may reduce the claim denials for organization, and it can even identify the fraudulent claims also, which in turn can improve the AR for the hospitals and for the clinics as well. So that
Yeah.
I would say, having said that, so not only the prescriptive analytic. Yes, sorry, John, you have any question?
No, I had a follow up. Why don't you complete your trail of thought?
Oh, okay, yeah. I was just to say that it's not only the predictive or the prescriptive analytics, even the basics of like data visualization, the descriptive analytics is also is of very much on the rise in the digital industry, I would say, with respect to healthcare.
Yeah.
So in short, like I would say, there are a lot of opportunities.
Sorry, I think Prabhu, you spent some time in healthcare as well. I just wanted to, check your thoughts on, has healthcare not kind of caught up with other industries, mostly because of the payer provider divide, where the data is not necessarily, exchanged. Why do you think, healthcare has taken some time to catch up? Any thoughts there, Prabhu?
Right. See, in many cases, the use cases that people are talking about where they can use AI in healthcare is in the periphery of healthcare, right? So, for example, finding out health insurance frauds, maybe, or maybe trying to say, how many beds may be required to be free in a hospital, or how many patient readmissions can I expect in the next 3 months, provided that this is the condition that I'm going through, and so on, right? So these are the peripheral questions in healthcare, right? So unless you affect a question that is going to touch upon either RCM for payers, where they are trying to manage revenue cycles, or you're trying to look at how the payers can, RCM for providers, and the payers can look at reducing their premium or maybe providing a better customer experience and so on, which has to be in the core of healthcare, right? Unless we start doing that, I don't think there will be a lot of catch up, right? Healthcare, of course, is using a lot of AI. I would disagree when we say that healthcare is actually catching up, but I would rather say healthcare is taking lots of leaps and bounds in using AI, but they're all in the periphery. Why they don't get to the core is because AI is probabilistic in nature, right? So when you are talking about the core of healthcare, probabilistic is not good enough. You have to be deterministic to talk about what kind of problem a particular person is facing and so on. There are some cases where AI also has gotten into that deterministic frame. For example, there are quite a few models, even open source models out there right now, which give a diagnosis of a person having COVID or not, provided his chest X-rays and radiographs, right? So, given that there is good catch-up that's happening, but I think it's not going to take a long time before AI plays a considerable part within the core of healthcare.
Hey, thanks, Prabhu. Just a quick time check, and we might speed up. And we are having some questions from our attendees as well. So, Sundar, quick question to you. What are some of the recent trends that you're seeing in very mature data science practices? What are some of the new technologies and processes that they follow? And if you want to also talk about within that, what are some of the tools that folks are using in data preparation today?
Sure. I think let's start with the data preparation tools. I've seen a variety being used. It sometimes comes down to the skill set of the person who's actually doing the job. People who are generally comfortable with coding resort to Python mostly. depending on where the data is stored. We use a combination of SQL, Scala, etc. for both pre-processing, cleaning the data, and all that stuff. So that's what I've Python is probably the most trending, popular, whatever you want to call it, easy, intuitive to learn, and everything. I think Prabhu, it used to be popular in the electrical engineering days. People who do VLSI design used to use Python a lot back then. Wouldn't have imagined we would have used it for this now. So I think that's pretty popular. At the same time, there are a lot of tools in the market where less coding is needed. It's more visual and makes the job easy for somebody who's just getting into the field. Trifacta, Alteryx, even the cloud vendors like Amazon and Google. You have many tools out there now that can aid in some of the processes here. So that's the trend I'm seeing in terms of tools. There are more and more. It's hard to even keep up with it these days. Yeah.
Hey, thanks, Sundar. Quickly on that note, Sudha, do you want to talk about what Kanini does? Especially around the data preparation side, and what does Kanini do in the analytics, data sciences side of things?
Yeah, sure, John. And that was an interesting discussion that we had on the data science, like speed versus acceleration. So thanks, Sundar and Prabhu, for the quick insights that you had given to our audience. So coming to the data analytics practice, Kanini is a digital 2.0 transformation enabler. We help our clients enable their digital transformation initiatives. So we focus on cloud enablement, analytics and AI, service now, and product engineering are the main focus, with the industry focus on, I would say, like healthcare, energy and utilities, financial services, and government sectors. So coming to the capabilities that we offer, I mean, we have as part of analytics practice, we have consulting and business intelligence services, data engineering services, and then data science experimentation. Like we provide end-to-end services with the data collection, data preparation, coming up with the prediction models, and then data visualization. It's supervised machine learning or unsupervised with X analytics, like it's with text, image, audio, video, and sentiment analysis. And coming to the tool sets, I think whatever Sundar you had mentioned, it's predominantly the industry standard tool sets that we are using. When it comes to big data, we have Hadoop and we have Hive and MongoDB. And we do have like Kafka, Python, or all the programming languages. And in order to, we discussed about the challenges that we face with speed, right? So in order to cater to that challenge, we also go with the pre-trained models, like it can be Google BERT or Word to VAC or FLAR for the sentiment analysis and text analysis. And we also offer, like we leverage the cloud-based solutions with Azure ML platforms. And coming to the solutions, Kanini has conversational AI solution and ML360. Conversational AI is a bot platform which helps improve the customers, improve their satisfaction with the 24/7 customer service availability, and it actually handles voice and text analytics. And it's basically it has like a sentiment analysis. It can follow up with the patients in healthcare, and also we have utilized that in the financial services in handling the customer inquiries. It's again an open stack, and it's scalable. Right now, like we do have both supervised and unsupervised machine learning algorithms included in that. And we'll delve into details of ML360 maybe in the later presentation, later part of this presentation.
It is.
Sorry, go ahead,
it's very good to see that that Kanini is trying to approach every component of complexity from your ingestion all the way to preparation, modeling, and even multiple use cases as conversational bots, as well as on the modeling side of things with ML360. I feel it's good to hear that you're trying to tackle every bit of complexity, because that's what will ultimately speed up to get to the solution, which is what matters from an ROI perspective. So it's good to hear that you have strategic and your thought process is in the space.
Yeah,
Hey,
right. Thanks,
thanks,
Sundar.
Sundar. Sudha, do you want
Yeah.
to talk a little bit about ML360? Given you touched on that.
Yeah, okay, sure. Yeah. So this ML360 is Kanini's custom-built, scalable ML solution to support the business users and data scientists to get quicker insights with the prediction model. Like we have like problems to solve, and then we have touched upon, like as Sundar mentioned, we wanted to see like come up with a holistic view of solving a problem. We define the approach, and then so we have the data processing, data collection, and then predict the model. So this is easily scalable because of the open source tech stack that we had used. And it works for both classification. It can be a binary classification or multi-classification, and regression models also. And it's generic, but it's not for just one use case, but can be used for multiple prediction use cases. One example I would say for this ML360 is like we had deployed is for the patient population health analytics, where the demographic details of the patients are provided as the input, and the data model is built with the data types, and then there are multiple models that's built. So multiple algorithm accuracy results are provided, and then data visualization is also part of this ML360. And this is very transparent, and it's easily customizable with the intuitive user interface. With
Thanks for that.
respect to data visualization, yeah, we are not yet into Tableau or Power BI, but it's with this ML360 platform itself we had come up with the visualizations.
Awesome. Do you want to talk about any outcomes that some of Kanini's clients would have seen based on what the data scientist team were able to offer to them?
Yeah, like there are many problems that we had identified across the industries that we had come up with, like say, for example, in healthcare, and it can be a payer analytics. For energy and utilities, there are like problems with respect to the risk analysis. And with respect to the financial services, again, we have like, we wanted to reduce the time taken for the audits, for coming up with the fraudulent claims or fraudulent audits, I would say. So these are the outcomes when it comes to coming up with the predictive analytics. Say for one of our clients, who's Fortune 100 financial service provider, we had come up with a data model in identifying the fraudulent transactions and the audit transactions that has improper data. And so this model provides you with the visualizations and with the reports on the invalid audits, and this reduced the time taken by the auditors. It reduced approximately to 30%. That's one of the outcomes, I would say. And when it comes to energy and utility sector, for one of the major gas distribution utility provider, there was a compliance by DOT with respect to transmission of the gas across the states. So the client organization, they wanted to have a risk analysis and then come up with the predictive model for providing the risk analysis based on, say, for example, corrosion, there is a failure in the transmission line. We had management pipeline. We assign a scorecard, risk scorecard for each of the failures, and come up with the risk score. So this actually reduced the field visits by the inspectors, and because the lifetime of the assets are improved, and it can be easily replaced So this results in the reduction in the field visits by 20%, and also there is reduction in insurance liabilities by 25%. So this is one of the major, I would say, one of the major outcomes with respect to the energy and utilities sector.
Interesting, right?
Because
Interesting, to look at the assets, to gauge the lifetime of the assets based on multiple parameters of their corrosion, of where they are, any joint weld failures, and then therefore have a predictive maintenance there. Absolutely, I think very interesting. Thanks, Sudha, for that. We have a few questions from our attendees, and if possible, before I go to that, we'll have one more poll. And as we get to the poll, more to understand what you're using today. Do you use any pre-trained data models? Are you using, cloud solutions? We'd like to see, what you're using in your organization. I'll go with the first question from Parnagiri Dinesh Lakshmi Narayan. Data scientist, this is one buzzword that I'm exploring online, but not getting a concrete solution for a long time. At a high level, I understand it is a person who analyzes the data and prepares data worth terabytes or maybe petabytes, right? Preparing data really takes time and can be error prone with such a huge amount of data. What is your take on this? I'm assuming, Dinesh, you're asking about human talent working on data preparation. And I think that's the question. Sundar, do you want to take a shot on this and give your thoughts there?
Sure. So I can start by saying we cannot avoid it. It's a problem that needs to be solved. So if the data is messy, or if data preparation is a challenge, we'll have to, the scientist finds a way to overcome it. But I think the question was, they were researching, trying to find out what the data scientist does. I believe that was part of the question. It's not just for preparation alone, but it's more about trying to make a decision from the data, or trying to build a product that drives better customer experience, or solves a specific problem. That's really the ultimate outcome that you want to achieve, and data preparation is a component within there to get to that outcome. That's the way I would think about it. And yes, it could be error prone, which is why that step is important. Cleanup is part of that process. The reason you clean things up is sometimes you remove certain things. At the same time, there is something called imputation, which is you add data when it's actually missing. So there are specific ways to overcome it, to address those challenges.
Thanks, Sundar. Sudha, quick question from Ram Kasi. How does a typical data science solution pan out? Does it always start with a use case in mind, then start scouting for required data sets, or start blind data exploration and start looking for hidden nuggets and form a use case out of it?
Yeah, interesting question. So I would say, I would say, like, we first take the business driven use case, because we have to identify what the problem is, because identifying the problem is very important. Without that, we may not be able to get a solution. We need to know where we want to go, what is that we are trying to solve for. So first we have to identify the problem. Hey, this is my problem. How do I approach this problem? And then comes the data preparation. What kind of data sets that we want to get with? What are the various sources that I can get the data sets? It can be from the customer data if it's my existing customer, or it can be from the social media, or from the other data platforms like Nuggets or whatever it is. So I think we need to define the problem first, and then we need to address the problem. And when it comes to addressing the entire solution, we may need to design the approach, and then see whether we want to come up with what is the prediction models that we have to come up with. So, but without identifying the problem, I don't think we can go with any solution.
Yeah, so Ram, part of what Sundar answered as part of the overall life cycle, would also give you, hey, what does a typical data science solution pan out, right? Starts with identifying the problem, the domain expertise, then, looking at data, data prep, the exploratory, playing with data, the exploratory analytics part of it, and then getting into the feature engineering, data modeling part, and finally, then the maintenance and the recalibration. So I think Sundar also had a response earlier. Now going to a question that Radha Krishnan Ramanujam had, now directing this to you, Prabhu. I have Java-based applications which run on Linux, Solaris, Red Hat. Here is the issue. During business hours, some application instance goes down. I do see errors in the log file like out of memory, stuck threads, etc. My question, how do you apply AI in this case and find out which part of the application code is causing the issue, right? Yeah, so a live use case that you're getting, Prabhu. Uh, yeah,
So
go ahead.
you can actually write a book on this, right? So and there are
Right,
several products making their revenue out of this use case, right? So there is no one single straightforward answer to this question, but no, it requires a lot of understanding about the application and how it's coded and stuff like that as well. So there are automatic analyzers which look at the application and figure out what problems can happen where, based on the repository of problems that could happen with a particular style of coding or with a particular way of how the application is structured. So based on that, there is a repository or a data set, right? So in our language, it would be a training data set that could be formed, saying, okay, these are where the application could go wrong, and this could be the reason if it goes wrong in those cases, and so on. So you use that as your training data set to train the model, and then let the model know, okay, this problem could be because of this. But it's not straightforward because you're going to have to fail that code so many times to make that model more accurate, right? So
right.
that goes against the principle of saying, my code should work good. In this case, you will need your code to fail so many times for your model to get accurate. So there are a lot of people like Logstash and so on who are making good revenue out of this and have turned this into a business model, right? Where they have actually looked at several applications, across the world, which have done this and which have failed. So they have a good repository. So having a good repository of your failures and things like that is key in understanding this. So that's the answer to that question.
Hey, thanks, Prabhu. We have a final question here, from Babu. Sundar, directing it this to your way. Considering the rapidly changing business scenarios, how do we determine the shelf life of a data science solution, which in turn will impact the ROI? I'm assuming, the question is more about how often do you need to optimize? How often do you look at the maintenance optimization of the, models, Sundar?
Sure. The main thing to look for is its relevancy, and the part of the cycle is how useful is it today. If it's useful today, then the shelf life is still there today. And if you can predict that something is going to change in the future in 3 months, 6 months, 6 years from now, you can actually tailor towards that. But more often than not, you don't know what's going to change in the future. And even if something is going to change, you don't know exactly, something's going to change. You don't know exactly you don't know what the change is going to be, right? So it's uncertain, which is why the concept of a minimal viable product becomes very important, because you don't want to invest in big and build a rocket to cross the street. So having a minimal viable solution and monitoring it as it goes, how well it's performing. If it's not performing well, knowing why will help address the shelf life. If it's not performing well because the problem is not relevant anymore, versus the problem has changed and you need to enhance your application to get there, will help you address the shelf life of that specific solution. The other thing also is what used to be a manual effort, a lot of time, can now be bought. So being open, all of us want our code to be implemented in production, and we want our name written all over it. Having an open mind for building versus buying is another way, and the only way you will know whether it's worth buying is if you're keeping up to date with what's out there in the industry, and that may tell you that the shelf life for the current product is gone. You might as well just buy this and outsource this, or use a cloud vendor service to do it, and so on. So that's kind of will address some of the shelf life and being able to stay up with the market. And Sudha mentioned about problem first, use case versus and the problem there. And just want to link this to that. I have seen both happen in our situation. Meaning, when you have a problem and you try to solve it, you build credibility. People need to trust you when you're solving problems for them. So you build credibility there because you're solving a relevant problem. At the same time, if people don't know what the solution is capable of doing, they cannot come up with a business problem where AI can apply. So sometimes educating them and saying, with a word to work, I can identify is a king close to a man and a queen close to a woman, things like that. And you give real examples or show what you can do with computer vision and beyond just object detection and so on, because there's no problem to solve. You're just demonstrating what can be done technically, inspires use cases. And we do hackathons and all that all the time. I mean, we see both, and sometimes it helps you address a future shelf life for it, because if you know this is possible today and you can get there in 3 to 6 months, you may sunset something that exists previously as well. So I don't
Thank
know
you.
if that partially
Yeah, I
answered
think I think you probably got that covered. I think we are to be very exact 6 minutes overboard. I want to take the time to thank all of you who took the time to listen to us. Sorry, did someone have a question? Okay. If not, wanted to take the time to thank all the speakers, Sundar, Prabhu, Sudha. Thanks for your time and valuable insights. I just hope everyone who joined us today are going back with a few tricks that you picked up from here. There's an ebook that will reach all of our registrants within the next 48 hours. And if you have any questions that you want us to sort offline, do write to us at transformations@kanini.com. Again, it's transformations@kanini.com. You'll also find the recording of the event in our What's New section of kanini.com, www.kanini.com within 24 hours of the event. Thank you all again. We're signing off for now. Have a good rest of the day or night, wherever you're logged in from. Thanks all of you.